Hello, students. We are into Math Connections 7.5. For this section, I've assigned 2, 4, 2, 3, 4, 11, 14, 15, 16, 19, 20, 21, and 24. So 1, so 3, 6, 7, 8, 9, 10, 11 questions. So not too bad. Let us take a look at those 2 through 4. Find the value. Here we go. Find the value of square root of 3 on the calculator and explain why this cannot be the exact value of the square root of 3. Remember, if it is the exact value, I should be able to multiply it by itself and get back to the number 3. Your calculator most likely will terminate at some point, and you'll have to show that it works or doesn't work. Let's see here. 3, is it true the square root of a plus b equals square root of a plus square root of b? For all of them, wow, this is an always, sometimes, never question. Whew, gotta love that. Right? So I'll let you choose. You can pick some numbers and put them in. You can use your calculator to check yourself, but that's the goal. And this is number 4. The number 22/7 can be written as an infinite repeating decimal. Could pi equal 22/7? Now remember, pi is an irrational number. So is this possible? Make sure your explanation links to the terms that we've been using in this section. 2 through 4. Next one is 11. I think that's down here at the bottom. Could you find a number that is both irrational and an integer at the same time, right? Is that possible? Wish I knew. Wish I knew. I wonder if that is possible. If it is an integer, what does that mean? If it is irrational, what does that mean? Okay, so that's what we're looking for here. Let's see here, 14 through 16, come up to the top. What is the difference, if any, between the opposite of this thing squared and the opposite of this thing? Oh, this goes back to chapter 5. You might remember, and I remember some of you were struggling with it a little bit, but we wrote something like this and something like this. This question is kind of honing in on that again, the idea of the opposite coming into play here with exponents. Okay. Jim says if square root of 2 can be written this way, which it can, it absolutely can, why is it not rational? Okay, so again, everything in this class seems to tie back into the idea, what is a rational number? What does it mean to be a rational number? Use that as you do it. A student claims that the square root of a plus square root of b quantity squared is equal to a plus b because we know these two things. And notice this is not that unlike a student who says x plus y quantity squared is x squared plus y squared. Are they correct? And this one did. That was also, it ties back into a question from the classroom in a previous unit. Okay. Let's see here, 14, 15, 16. That was it, 14 to 16, 19 through 21. Let me skip down a little bit. Not that these other ones are bad. They just, I think sometimes the authors got a little bit beyond the scope of our class. Our class is only supposed to go up to 8th grade. And we're pushing the limit here with nested square roots. So I'm not going to go through and do that. 19, a student noticed that the cube root of 5 is less than 5 and wanted to know that if a is greater than 0, the cube root of a is less than the square root of a. How do you respond? All right. Well, we've seen things that are, hey, if I multiply a number by itself, it's bigger. Or sometimes it's smaller. There was a relationship between that concept and what we did with multiplication, the multiplication identity element of 1. So maybe that nudges you in the right direction. Maybe there's a reason why it works this way for some numbers. Maybe it doesn't work this way for all numbers. Find a counterexample if you can. All right, we got Jose now. Jose says the equation square root of the what looks like negative x equals 3 has no solution because the square root of a negative number does not exist. You have a chance to show Jose something about maybe terminology, but also maybe thinking about what that represents. And lastly, a student wants to know what's wrong with the following proof. Oh, I love this one. So a student says square root of a times square root of b equals square root of ab. That's actually 100% true. That was one of the theorems that we talked about in this section. And they say, okay, well, let's pick a and b and let them all be -1. So the square root of -1 times square root of -1 equals the square root of -1 times 1, because that's what's listed here, equals 1. But also, the square root of -1 times square root of -1 is supposed to equal -1, just like what we saw earlier from the square root of 2 times the square root of 2, that has to equal 2 by definition. So therefore, in one case it equals -1, in one case it equals 1, so we know -1 is equal to 1. What do you think about that? Where is the student on the right track, and where might they have stepped off the path? And lastly, I need number 24. Take a look at Mark's work. Mark is now simplifying using the technique that I showed in class. Think about just dividing it in and see if his work is good. Maybe he has made an error, maybe not. Okay, so think about that as you do it. Phew, that's it. Again, you may have questions over these. Please let me know if you do. We can certainly go over some of those in class. I can also respond with a video, meet you in person on campus. I can meet you after class, or we could, of course, jump into Zoom together if you prefer that. All right, off you go.